In time of war, combat damage to military aircraft is inevitable. But some aircraft will survive that damage and return to base. It is vital that these aircraft are made operational as soon as possible. Aircraft that survive combat damage need battle damage repair to enable them to perform the next mission. We may no longer have the peacetime luxuries of ample spares, tools, personnel, power, and of course, time. Therefore, battle damage repair has evolved philosophies and techniques which are quite different from those of peacetime. The aim of the Royal Air Force in peacetime is to train for war. Training in battle damage repair techniques is given to prepare personnel for that day. The Royal Air Force has established an ABDR training school where personnel are instructed in the special needs of battle damage repair. Training starts with the theories behind BDR and their application to combat aircraft.
If time and environmental constraints permit, the primary aim of aircraft battle damage repair is to restore the full static structural strength and operational capability of the aircraft, but not the full fatigue life. The secondary aim is to make the best possible repair in the time available, and in this case the assessor would need to provide his operational commander with limits for the repaired aircraft. I'd now like to draw your attention to some of the techniques used for the rapid repair of battle-damaged aircraft. The top hat frame is one of the methods of repairing damaged frames and will adopt most curvatures. The double splint method is just one technique used for repairing damaged control rods. In testing, the fork end on this specimen failed before the repair itself. The air-equipped hose and its adapters is an excellent method of repairing damaged hydraulic pipes. And finally, on the electrical side, these inline splices are one of the methods used to repair damaged electrical cables. I'd now like to draw your attention to the Gazelle tail boom, which illustrates many of these techniques actually used on an aircraft. For instance, the control cable repairs, hydraulic pipe repairs, the substitute frame repair, and a metal skin repair, which shows some of the fasteners that can be used in BDR. On the fin and the tail end, you can see a repair technique that's currently under development, and that's the use of carbon fibers for repairs to damaged metal structure.
Students then start putting these theories into practice. Workshops are available where instruction is given into the basic BDR repair techniques and their further specialist applications.
It'll be okay. So if you'd like to move it along and carry on sawing.
Right, now tighten the blank.
Testing of repairs allows greater confidence in the use of these techniques.
When you've got the safety screen on, pressurise to 4,500 psi. Okay?
The techniques learned in the classroom are put into practice on complete aircraft, so that an appreciation can be made of the problems involved in applying BDR techniques in real repair situations. Confidence is gained in the use of the specialist tools on various airframes. Particular emphasis is made on the importance of the team effort, all part of achieving the task in the shortest possible time. Some of these techniques have had validation under wartime conditions. However, a general war in Europe would present a different scenario from that experience to date. An aircraft which has suffered survivable damage returns to base. The decision-making process starts. Airworthiness is the question. Can the aircraft fly again? Because an aircraft has returned to its base, it does not guarantee that there's sufficient structural integrity remaining for further flying. Stress factors would increase with a full weapon and fuel load. So, can the aircraft be made fit to fly a useful mission? It is important to first determine the extent of the damage. The aircrew debrief is the first phase of BDR, providing us with vital information on the effects of damage on the capability of the aircraft. Remember, what the assessor sees from the outside tells us nothing about unseen damage deeper inside the airframe, particularly to systems and wiring. A face-to-face, post-flight debriefing between aircrew and assessors establishes areas for investigation.
We took a hit in the port wing coming off the target.
Any flight control problems?
No problems, but we lost all the main flight instruments.
Port wing damage probably extends to the pedostatic system.
Yeah, and we lost all our main radios on the approach.
Right, sir, we'll take a look.
Thank you.
Okay, you take the top, I'll take the underneath.
Okay.
The assessment task is the second phase of BDR, establishing the full extent of the damage. Emphasis will be on following through the trail of damage. Any damage found will be marked with relevant repair symbols and noted. A careful inspection is made of all the damaged areas to establish the exact nature and full extent of the repair needed. Small arms fire has made holes into a fuel tank. These will require sealing. Where entry holes exist on panels, the panels are removed to establish the full extent of the damage. In this case, to the wiring loom in the spine. Having assessed the damage, it is then necessary to report the findings to the squadron management.
What's the extent of the damage? Internal structure is sound, sir. We need to put scab patches top and bottom. We have pedostatic pipes damaged at the front. We need to cut an access hole to get in through the skin.
Okay, and electrics?
We just got one cable assembly which has been severed. Only two of the cables need to be repaired because it's the pitot heater, and the others I will cut back and insulate.
Fine. What about the damage on the spine?
We can speed tape the two holes on the spine, sir, and the fuel tanks we will repair by patching.
Okay, and electrics?
We've got two cable assemblies in there with cables severed. One goes to your radio supplies and the other is for your RWR.
Okay, well, you'll have to repair at least one of the radios. The aircraft could fly without the RWR, and I'm sure the squadron boss will want it fixed.
Yeah, okay, so.
What functionals are you going to do?
Pedostatic leak and stench checks, RWR checks, and radio checks.
Okay, fine. How long is this going to take?
This repair is going to take 6 to 8 hours, sir. I'll need 2 extra men.
Okay, I'll give you 2 men. Give me hourly reports, will you?
Okay, sir.
Armed with the knowledge of repair timetables and mission requirements, operational decisions can be made. Before work commences, the tradesmen need the tools and materials necessary to accomplish the repairs. This BDR kit is mobile and modular in form. This makes for maximum flexibility in its use. Wherever necessary, reference should be made to the aircraft publication.
Plug 19, pin A.
Whilst preparations for the wing repair are being carried out, an electrical tradesman is checking the wiring loom on the spine, using a touch-sensitive circuit tracer.
Plug 19, pin B. Yep, okay.
The first phase of structural repair work is to clean out existing damage. This is greatly aided by using various powered cutting tools. Sometimes a hole has to be cut into good structures to allow access to internally damaged components. With the damaged areas now fully prepared, time should be taken to confirm that the proposed repair schemes are still valid. Having identified the essential electrical systems, damaged wires are crimped together and insulation is repaired where necessary. The panel is replaced. Speed tape has been used to cover the holes for weatherproofing purposes. Having cut a hole for access, the full damage to the pitot-static system can be established. Fragments have fractured a rubber pipe. A repair is made by a simple tube insert. The holes to the fuel tank are dealt with by a simple but effective bolt, crucifix, washer and sealant repair. With the damaged metal now cut away, repairs are carried out to any internal systems or wiring.
Pick the holes up on the rib.
Patches of a suitable material for that area of the aircraft have been cut to size and are positioned for marking and drilling. Although in BDR speed of repair is essential, waste is still a hazard, and removal of FOD is important.
Gas, gas, gas! Stop, stop, stop!
When necessary, personnel will have to spend periods of time working in full NBC gear. When fully dressed in NBC equipment, active work becomes more difficult. Vision and manipulative ability are impaired. A decrease in respiratory airflow, together with an increase in body heat, causes stress and fatigue and leads to a decrease in the rate of activity. Although power tools enable the work to be accomplished quickly, the task can still be carried out with hand tools. The patches are attached with appropriate fasteners, picking up existing rib structure where possible. The fasteners used in this instance are Joe bolts.
All clear, NBC straight white. All clear, NBC straight white.
If time allows, tone down repairs, particularly the larger shiny patches. But remember that aesthetics have no place in BDR. Although this damage repair did not require replacement of any structure, that will not always be the case, and sometimes the strengthening of a patch will be necessary, maybe using an external stiffener, which will be in line with the direction of airflow. The aerodynamic properties of an aircraft may not be so good after BDR, and this, coupled with other degraded facilities, may require limitations to be entered into the aircraft documentation. All repair work should be entered in the normal aircraft documentation for future reference by both aircrew and engineers. We need aircraft battle damage repair to quickly return combat aircraft to the battle area, to fight again, and so help maintain our effectiveness in any future conflict. Quick functional checks on essential systems should be carried out by the aircrew prior to the next sortie. The aircraft has been made operational again, but not, of course, to full peacetime standards. The sortie generation rate has been improved, and the war effort is thus maintained.